We're looking at a trinomial ax squared plus bx plus c, and we factored many such trinomials in previous lessons. But most of the trinomials that we factored so far, the value of a has been 1. And here is an example. A is equal to 1, b is equal to 13, and c is equal to 36. And you probably already know that you're looking for two numbers that have a product of 36 and a sum of 13. So our factored answer for the trinomial is the binomial x plus 9 times the binomial x plus 4. Well, now here's one where a is not 1, it's 3. And so we're going to take a look at 3, and we're also going to take a look at 5, which is the value of c. Well, they're both prime numbers, so the only factors of 3 are 1 and 3, and the only factors of 5 are 1 and 5. So one way we could break it down is shown here. 3x plus 5 times the quantity x plus 1. The other way we could break it down is to switch the 1 and the 5 around so that the 3x is in a binomial with the 1 instead of the 5 as it was in our first instance. Now let's take a look at the one on the top. We know that 3x times x is 3x squared, and 5 times 1 is 5. It's the middle term, the 16x that we're after. Well, we try 3x times 1 and we get 3x, and we try 5 times x and we get 5x. Well, 3x plus 5x is only 8x, so that one doesn't work. If this other one doesn't work, then the trinomial is prime. But of course, 3x times 5 is 15x, and 1 times x is 1x. 15x plus 1x is 16x. So this pair of binomials works, and it is the factored answer for the trinomial 3x squared plus 16x plus 5. What we've used is a method called trial and error, and one textbook I've used calls this method inspection. In some cases, it can be very frustrating. This might be one of those cases, 12x squared plus 28x plus 15. Well, the 12 and the 15 are not prime, so we're going to break them down. The factors of 12, of course, are 1 times 12, 2 times 6, and 3 times 4. And for 15, we have two pairs, 1 times 15 and 3 times 5. So we're going to start with just one possible combination. The x plus 1 is a binomial times the binomial 12x plus 15. And in fact, there's many more possible combinations, but only one of them will make the middle term 28x. And in fact, in some trinomials, none of them will work for the middle term, and then those trinomials will be prime. Well, if you want, you can stop the video and jot down what you think are some of the other possible combinations. And now, if you've turned the video back on, I'm going to show you some of the others. But you can still stop the video at any time and write some more, because there are a lot more. Here we have some at the lower left. The first group involved breaking the 12 down as 1 times 12 and pairing that up with both combinations that make 15. Now our current group is breaking the 12 down as 2 times 6 and pairing that up with the two pairs that make 15. And you can see in our third group, we're breaking the 12 down as 3 times 4. Well, there they are. There's 12 possible combinations. Well, in this method, trial and error, also known as inspection, we just start looking at them. So I've highlighted the first one in red. Well, 1 times 12x is 12x, and x times 15 is 15x, and they add up to 27x, and we're so close, but we need it to be 28x, so that one doesn't work. This one we can rule out much more quickly because the 15 times the 12x is way bigger than 28. The same here, 3 times 12x is 36. Certainly not way bigger, but too big, so we cross this one out. Here we have 5 times 12x is 60x, so we cross it out. Well, here we have 1 times 6x, so then we try 2x times 15, get 30x. 6x plus 30x is 36x, so that's too big. This one is going to be too big because 15 times 6x is 90x. And finally, we have 3 times 6x is 18x, and 2x times 5 is 10x. 18x plus 10x is 28x. Here's the pair of binomials that works. This trinomial can be factored into the pair circled, and we could ignore our other combinations because we already have factored this trinomial. Now here's one that involves subtraction. So we left our factors of 12 and 15 on the board, but the problem here is when we're subtracting 15, that means that one of them's negative and one's positive. So for example, it could be negative 1 times 15, could also be positive 1 times negative 15. The same situation applies to all the other pairs. So that means instead of having 12 possibilities, there's 24 possibilities that might be the factored answer for this trinomial. If you want to try to jot them down now, you may, or you may just take a look. And I'm about ready to put them up, and here they are, all 24 possibilities. You can see I had to go with a much smaller font to get them to fit. And rather than go through them one at a time, I'm just going to show you the one that works, and you can see why this method can be so discouraging. However, if you're really good with mental arithmetic, you can rule many of these out very quickly, and then you'll find the one that works. And there it is, because the negative 3 times 12 is negative 36x, and the x times the 5 is positive 5x. Of course, negative 36x plus positive 5x is negative 31x. That's the middle term we're looking for. So the circled pair of binomials is the factored form of the trinomial 12x squared minus 31x minus 15. So here's another trinomial, and we'll take a look at the 6, and we'll break that down as 1 times 6 and 2 times 3. And we'll take a look at the 21, and we'll break that down as 1 times 21 or 3 times 7. And then we notice that the 21 is being added, but the 23x is being subtracted. So it's going to be two negative numbers that have a product of 21 and two negative numbers that add up to negative 23x. So the form of our pair of factored binomials is going to be a number times x, take away a number, times another binomial, which is also a number times x, take away a number. So we're just going to put some of our numbers in. There's several combinations, and I've started with this one. But when I do the negative 3 times the 2x, I get negative 6x. And when I do the 3x times negative 7, I get negative 21x. And we're close, but negative 6x and negative 21x is negative 27x. So that one doesn't work, and I cross it out. But then, just trial and error, I'm just going to switch the 7 and the 3 and try that. Well, for my inside terms, I get negative 7 times 2x, negative 14x. And then for the outside terms, 3x times negative 3 is negative 9x. And I've hit the jackpot. Negative 14x plus negative 9x is negative 23x. So this is our factored form of the top trinomial, and I'm going to rewrite it all in one color and a little bit bigger. The product of the binomial 3x minus 7 times the binomial 2x minus 3 is the factored form of 6x squared minus 23x plus 21. When factoring polynomials of the form ax squared plus bx plus c using trial and error, sometimes called inspection, write pairs of binomials in the form mx squared plus j times nx squared plus k, where the product of m and n is equal to a and the product of j and k is equal to c. Do this until the product of one of the pairs of the binomials is equal to ax squared plus bx plus c. If none can be found, the trinomial is prime.